as Swadhin already introduced me, so let me jump into the topic of the day. So this is machine learning, the science and engineering. So I am Soumya Basu. So I am currently with Google, and before that I did my PhD in UT Austin, and that's how I like met Swadhin and spent time with him. So yeah, I'll come back to my background later on, but let's start with the talk, the machine learning. So what is the buzz about machine learning? Let's try to understand that. So what this picture is saying is that you have the game of Go. So Go is this very ancient game and very sort of intricate game where you have to come up with this strategy, and what you are trying to do is you are trying to cover as much area of the board as you can with your tiles, which can be black or white. And there are some rules that says that if you can sort of circle around a particular area, that becomes yours, and then this game goes on as people like sort of start grabbing area. So this has been like a very challenging game for humans, and as we know that humans have like uh, humans at this point has this very intrinsic sort of intelligence that can cover this long range games and then pick up very nice strategies. The fact that there is a particular artificial intelligence sort of algorithm named AlphaGo that can beat the master Lee Sedol of this game Go. That was like a very big news. And then next, where what we are seeing here is like we have this structure. So this structure is of a protein, but then the question is like if you are given a basic knowledge of a protein. So what is a basic knowledge of a protein? So when you have a protein, what you the way you can express it is like a chain of amino acids. I think people who are like sort of taking biology in their 12th, they will probably have like more fresh memory of these things than I have. But the challenge here is to like to look at the sequence of amino acid that is basically a 1D structure, like just a few sort of like few alphabets describing this amino acids in a sequence, and from there you have to come up with this 3D structure where this different amino acids somehow like interact with each other differently and then combine in a very complicated manner to create this kind of very complex structures. So this has been a long standing challenge, and then people have like tried to sort of create different hand tuned algorithm that can increase the accuracy for predicting the structures given this chain of amino acid description for proteins. Very recently what happened is like so Google DeepMind, they designed an algorithm called AlphaFold that is also this machine learning based, and then it ended up predicting this structures with very high accuracy. And it's very important in like in the sort of progression of humanity, because like once you can do this kind of protein folding very efficiently and very fast, then you can use that knowledge to design a lot of drugs and a lot of other interactions you can sort of discover about in the field of medicine and so on. So and this is another project that's going on uh, where you are trying to look at this images, sometimes not very fine images of the retina that you can take and then look for certain signs of diabetic retinal diseases. So previously what used to happen, like there is a lot of man hour that used to go for figuring out whether a person has a disease or not. That created a bottleneck, and then that sort of restricted how many people can be checked yearly. So here, like, yearly checkup is very important. If you can catch this disease faster, then you can, like, stop the damage that can be caused by these diseases. And specifically, like in developing countries like India, where you have a lot of shortage of like medicinal facilities, there when you can design an algorithm that can sort of look at this image and say, okay, I mean, whether you don't have the disease or you likely have the disease, then you can, like, sort of figure out which persons should be taken to the doctors for further checkup. So Google's AI team, they created a machine learning based algorithm that can sort of look at like many such images which are like labeled as diseased or healthy, and then from there they can automatically sort of help the doctors to figure out whether some particular person's retinal image shows signs of like disease or not. So all of, like, these are just only three things, like you must be knowing about like a lot of other things going on, like self-driving being touted as like the next big thing that will be like completely dependent on AI on figuring out how to navigate this real world. And there are many things like one of these are like NLPs, where you can give any text from language, and then you can translate into other language automatically using machine learning. And I mean, the list just goes on. So basically, what we can say is that machine learning is really magical at today's age, and then the realm of magic will just keep increasing as the days progress. So what I'll try to do is like sort of give some glimpses of this type of these problems, and then go into a very basic uh, like primer sort of knowledge of machine learning, both in the science parts where people like use maths and statistics. So statistics is just sort of, if you don't know about statistics, what statistics is like, you use probability. I hope like you have some basic knowledge of probability if you're taking maths, and I assume that you are mostly in like 11 or 12 in, I think, like in the West Bengal curricula, you have like probability around that time. So yeah, you use some basic probability, like some basic maths knowledge to sort of create a model of all this possible data that you get, and then from there you are trying to sort of understand how to go about figuring out whether some retinal image is diseased or not, or how to do this protein folding. So that is the science part that we'll touch upon. Then the engineering part is like when you have like millions of such images that you want to process, like in a real world system, how do you go about it? And even beyond that, like how engineering sort of facilitates a lot of things that is not possible without thinking through that. I mean, you might have like a mathematical tool that can compute and say a lot of things about a particular system, but unless you can implement it, like, and do the computation efficiently, there is no hope. So we'll look at that angle as well. So before going into that, let's sort of try to look at some of the things that I talked about. And
Go is the world's oldest continuously played board game. It is one of the simplest and also most abstract.
Beating a professional player at Go is a long-standing challenge of artificial intelligence.
Everything we've ever tried in AI just falls over when you try the game of Go.
The number of possible configurations of the board is more than the number of atoms in the universe.
AlphaGo found a way to learn how to play Go.
So far, AlphaGo has beaten every challenge we've given it, but we won't know its true strength until we play somebody who is at the top of the world, like Lee Sedol.
A match like no other is about to get underway in South Korea.
They said all is to Go what Roger Federer is to tennis.
Just the very thought of a machine playing a human is inherently intriguing.
The place is a madhouse.
Welcome to the Deep Mind Challenge.
The whole world is watching.
Can Lee Sedol find AlphaGo's weakness? Whoa. Is there, in fact, a weakness?
The game kind of turned on its axis.
Look at his face.
That is not a confident face.
It's developing into a very, very dangerous fight.
Ooh, hold the phone. Lee has left the room.
In the end, it is about pride.
I think there's something went wrong.
Yeah, it's made a mistake.
He's got to pronounce a miracle.
These ideas that are driving AlphaGo are going to drive our future.
This is it, folks.
So yeah, they have a movie on Netflix on this development. So this was AlphaGo. So the one that I talked about, the first image that I showed. So what happened there is like they took a lot of this gameplay from like humans and experts, and then they learned from that. But then they later on figured out that because like in this game of Go, what happens is like you know all the rules, so you can play like yourself and then generate all the sort of valid moves. So what they did is, so this is the who are slightly knowledge and all. So this is a very good sort of resource to dig deeper into all of this stuff. So this is the blog of like DeepMind blog. So you can look into this blog and then sort of get some ideas of what's going on in, like in the boundaries of AI. So here they are talking about this thing where they don't take any data and then just then like from scratch they learn about it. So this is a very big thing because collecting data is not always possible. So, but you might have some idea about how the sort of world to operate, like what are the rules of the game, if you may say so. Yes, try to look at.
AlphaGo has been through many generations now. The first generation of AlphaGo, which we published in our original Nature paper, was able to beat a professional player for the first time. Now we have the final version of AlphaGo, Alphago Zero, which has learned completely from scratch, from first principles, without using any human data, and has achieved the highest level of performance overall. The most important idea in Alphago Zero is that it learns completely tabula rasa. That means it starts completely from a blank slate and figures out for itself only from self-play and without any human knowledge, without any human data, without any human examples or features or intervention from humans. It discovers how to play the game of Go completely from first principles. So tabula rasa learning is extremely important to goal and ambition mind, and the advantage from the game. For us, the idea of AlphaGo is not to governments, but actually to discover what it means to do science and for a program to be able to learn for itself what knowledge is. So what we started to see was that AlphaGo's an opening, learned them, discovered them, and ultimately discarded them in preference for its own variants, which humans don't even know about or play at the moment. And so we can say that really what's happened is that in a short space of time, Alphago Zero has understood all of the Go knowledge that has been accumulated by humans over thousands of years of playing, and it's analyzed it and it's started to look at it and discover much of this knowledge for itself. And sometimes it's chosen to actually go beyond that and come up with something which the humans hadn't even discovered in this time period, and developed new pieces of knowledge which were creative and novel in many ways. We're all really excited by how far Alphago Zero has come, but I think what we're most excited about is how far it can go in the real world. That The fact that we've seen a program can achieve a very high level of performance in a domain as complicated and challenging as Go should mean that now we can start to tackle some of the most challenging and impactful problems for humanity.
Soumya, like the video is lagging and
Not good.
getting choppy.
I
So I guess you can share the link of those videos on the chat
Yeah,
or later. So you can kind of go ahead with that.
yeah,
So, and if anyone have any questions, you can kind of write
yeah. This
chat.
is a good point to ask some questions about this, maybe the
Uh,
applications, and then I'll go into like some more like sort of what goes on in the background of all of these
Yeah.
things
So
in a
if
very
somebody has
time-oriented.
any related questions like kind of diving deep, so it's like an overview or like if you have any query or like general questions about this, you can. So there is one question I don't know if I understand that question really correctly. So somebody is asking, do you use Atom as a code editor? Okay. So they want to know what
Oh,
code
okay.
editor to use. So this is a very
I
specific
mean,
question. Yeah.
Atom was good, so I have tried it. But right now, no, we have like so I generally like use Google's internal sort of code editors. Yeah, but
Okay.
Atom was good, and I like when I was doing my research, I was mostly like sort of using this code editor, like the no IPython notebook or Jupyter notebook that is there. So it's something different. But yeah, I mean, go with Atom, and then there are many other like basic ones. Uh, yeah, I think it should not matter that much, at least not to me. Like just choose any code editor that you feel good. What is the other one? Is there any Google form or something? Oh, okay. Yeah, that's for you, I guess. Yeah, so if there
Yeah.
is no other, then I'll share this links.
Yeah.
Yeah, let's go on to the basics of machine learning. So the first question is like, what is machine learning?
So
So if you just look at,
there is a question like I'm just
oh,
reading out. Shubham is
yeah,
asking,
sure.
while making the algorithm for AlphaGo, there are like huge number of possibilities for the next step.
Hmm?
Other than the tackling the optimistic approach the opponent, how do you calculate the most efficient move? So if you have any idea,
So
yeah.
basically, like it's slightly detailed. So what you do, like generally, I mean, I don't know the AlphaGo algorithm in like full details, but what you generally do in this kind of problems is you sort of play the game for some, like you simulate the game as such for some amount of time, and then compute like for each of the intermediate. So you cannot play it till the end, right? I mean, there are like infinite, almost infinite, like it's so large, like it's practically infinite possibilities. So what you have is that you play it for some amount of time, and then for each of the moves that you can take, right now you sort of assign a score based on where it goes after some amount of playing. And yeah, I mean, there is a lot of like efficient computation that goes on. Like you figured out, okay, this is not a right, like useful direction, you don't go that, and then sort of scan some other efficient directions. So yeah, I mean, it's a combination of doing this simulation, like you play the game for some time, you figure out if you take this particular move at this point, like in some in the near future, where you'll go. And then you have to like, then the algorithm itself like tunes like how much deep you need to go, and then like what, given like whatever you have seen from the opponent, like how you figure out the opponent will play, and some things like that can come up. But yeah, I mean, it's a very difficult question to like explain all the details here, because it has taken like so many years, like decades, to come up to this level, and there is a lot of things that goes behind. this success.
Soumya, there are like many questions. Like you can kind of
Yeah, I can
yeah, you can
answer.
read directly. Yeah,
Okay. In the chat box, right?
yeah, I can tell you for easier
No,
for
no,
you.
it's fine. I
Yeah, yeah,
see.
yeah.
Let me try to see. Uh, we- so there's the Google form. Yeah, I mean, so the question is, Amurtha Chakravarti is asking that whether it uses like principles similar to backtracking, and the answer is yes. Like it does something similar to backtracking, but the problem is like you cannot backtrack the whole thing, so you have to figure out like do some partial backtracking, and then uh, like because you don't know whether you'll win or lose, you don't like you have to very cleverly and using like some sort of uh, like ML ideas, you have to assign like some score to the partial backtracked position where you go to. By ML ideas, I mean like you look at the data, like data that you have from the past, and then from there you are trying to in like figure out what is the score of this partial backtracking, because you don't yet know that whether you'll win or lose. The yeah. So coming to the next question, like, is the score manually inputted or the algorithm chooses? Yeah. So you look at the past data and it is chosen by the algorithm, and that's the most important part. That you cannot manually input uh, because like there are so many possibilities. Then it's like post fixing some moves for certain sets. How will it handle the completely unknown set, or it learns itself? Yeah, so how will it handle a completely unknown set? So the idea is like there are there's some sort of patterns that are hidden for this for all this unknown situations as well. So you will try to like sort of figure out what the patterns is. Like humans also play like this, right? I mean, if you look at certain sort of development in the board, you so you take sometimes you take defensive strategy, you take like offensive strategy. In offensive you have like some specific strategies like that goes about like I don't know the game of Go that much, but in chess you have like very different like the openings, like how you go for the end game, how you like go for the beginning of the game, and things like that. So those patterns, like this algorithm also tries to learn. How it learns itself is like it just plays. There are two agents, like so one is alpha go like go that there is no learning itself. The AlphaGo Zero is what learns itself. So what it does is like there are two similar agents and they play with each other. And as they play with each other, some win, some loses, and then from that experience they figure out how to go about it. So what it knows is like what are the valid moves. I
So
mean, of course, it's not trial and error. There are like made like situations more than the number of atoms in the universe, so you cannot go for trial and error. But there is a systematic approach that I will not go into. So the systematic approach is like you play for some time, and then if you look at the past data and then figure out given this partial position, like in this intermediate position, what is the chance of your winning or losing, and then based on that you decide. Yeah, I mean, like if you play with an engine, they will have simple algorithms, not AlphaGo most likely. But yeah, I mean, there are uh, such.
I think you can kind of continue your talk.
Yeah, I
Then
think
we
like
can
it's just
yeah.
going deeper into this Go. So I'll take the last question whether Go is a deterministic game. And the answer
Yeah.
is yes, because there is like, you know, for a particular move or what your situation will be. So yeah, given that, I'll stop with the questions at this point, and
And
maybe
like
I'll
we can
come
come
back
back to the question and just to
later,
kind
and
of
then
yeah, just interact you, just যদি কেউ বাংলায় জিজ্ঞেস করতে পারে, they can ask directly in Bengali, like You
হ্যাঁ,
don't
হ্যাঁ,
have to.
মানে কারোর যদি বাংলায় জিজ্ঞেস করার থাকে লাইক জাস্ট ডাইরেক্টলি বাংলায় জিজ্ঞেস করতে পারো, কোনো অসুবিধা নেই।
কোনো
আমি মানে
অসুবিধা নেই।
জেনারেল টকটা এখানে বাংলায় দিচ্ছি না, কারণ আমি জানি না
Yeah,
সিঙ্ক আছে।
yeah, that's fine. But sometimes, like if people,
হ্যাঁ, হ্যাঁ, কারোর যদি বাংলায় জিজ্ঞেস করার থাকে লাইক কোনো রকম
yeah,
নিঃসংকোচে লাইক জিজ্ঞেস করতে পারো, কোনো অসুবিধাই নেই।
ঠিক আছে. Okay, let's continue.
Yeah, now I'll continue. So let's go with what is machine learning. So Wikipedia, what it says is like machine learning is the study of computer algorithms that improve automatically through experience. So like machine learning is a very broad thing, as you can see, like you give some objective to the machine and then somehow it improves automatically. That would be considered as machine learning. But let's focus on some specific settings. So the specific setting that I'll focus on here, you have like some sort of known information. So just to introduce some jargon so that people are like sort of in sync. Like some people like know a lot, but maybe not all. So what we have is like a known set of data and levels. So you have some data. So data can be like an image, and then the level can be cat or dog. Then data can be like a CV of a person. Then whether like the level can be okay, whether to interview that person or to like reject that application. Then yeah, for the examples that I told you, like it can be an image of a retina, and then like you decide whether it's a diseased like if the image shows some sort of disease or not. And then the alpha fold protein sequencing, what I talked about there, what you are trying to do is like given a particular 3D structure of a 2D or rather 1D protein, what is the sort of stability value, like what is the potential energy of that, so that you are trying to predict. Yes, I didn't go into the details of the of those things, so there you can check out later like what how this protein sequencing is done or how this retinal imaging is done. So yeah, so now what you do is like you take this data and then feed into an algorithm that is designed to look into the data and then keep on improving itself. I'll show some like very basic example how that is done like in some time. But then what it happens is like this once this algorithm has like looked into the data and then improved itself for some time, that it come up with this black box, like an algorithm where you can like just feed in the unknown data and then you'll get a label. So you feed an image and it will say that whether this image is cat or dog, like if you're just thinking about differentiating these two. So this particular setting, so this is a special case of machine learning. So machine learning is this whole thing where you have an objective and then the machine or the algorithm improves automatically. But here in this specific setting where you have data, and for each data you have like a data point, you have a level. So there you have the what it is called a supervised learning. Then you have like this another field of reinforcement learning where you are operating in a like for a time frame, like for a time duration, and then depending on your history, like what you have done, things can change, things like that. That is in the realm of reinforcement learning. Like AlphaGo is in that domain. Then there is unsupervised learning where you have like some sort of data and then you don't really have a label. So then you are trying to qualitatively like sort of figure out some patterns into the data that sort of tries to optimize certain objectives. So I'll not go into this other two domains of reinforcement learning and unsupervised learning. I'll just focus on this thing called supervised learning, where you have some data and then you have a label, and then from this known thing you are trying to figure out some hidden pattern and then do the prediction of your own. So when you have an unknown data and then you are trying to find a level, that is called prediction. And when you have a known set of data and then you are sort of trying to learn this black box that you will use for prediction, that is called training. So the outline of the rest of the talk is like I'll just give a primer of like what is the science behind behind the supervised learning. And it will be very simple. Like I'll not go into like any maths of it, but the basic ideas that goes on behind it, and then some sort of engineering aspects to it, like what are the interesting engineering thing that happened, and then that enabled the boom that we are seeing in the last, I'd say, like 10 to 15 years. Then slight sort of digression, and we'll just talk about my journey a little bit. Yeah, and that's how I'll end the talk. So yeah, that's about it. So let's go into the science part of machine learning. So here, what it's a very simple thing. So you have this 2D uh, uh, 2D sort of plane, and then you have some stars. So this is the data that you know, right? Okay. So you have this XY is the position of a particular point in this. Okay. So what did you talk about? Is like what this Occam's razor is. Like, is there any more question about Occam's razor? Okay, no. I mean, I'll come back to the clumped one. That will be an important part. But let's go back to this. So why this Occam's razor is important? So the basic principle is like you don't want to complicate your life further because you don't know about certain things. So here, let's take at this look at the same example. So the dark blue stars are like the stars that you're seeing, and then there are some unknown data, right? I mean, the unknown data is basically this light blue stars. So because you don't know this light blue stars, what happens is that if you are looking into more complicated one, then you are putting more restrictions to it that is not needed. So if you just look at the line, probably once you choose the line, you still can have some errors. But then because you are not putting more restrictions, then you will end up with most probably good performance on unseen data. So this performance on unseen data is known as generalization. That is one of the most important aspects of machine learning. So you have some known data, and then you want to do something with the known data, and then come up with this black box, and that black box will give you the result on unknown data. So you want to like have the best possible performance on unseen data. So this is this is mainly the usefulness of Occam's razor. So if you don't complicate your life choosing like the complex sort of options, you will uh, not restrict yourself more than needed, and then you'll have better performance on unseen data. So let me go back and check. Okay, so this is important. What do I mean by unseen data? So when I say that, think about the image of cats and dogs, right? So there are like how many? There are possibly billions of possible images of cats and dogs, and you don't have all the images that are there of cats and dogs in the world, right? So you just have like compiled some thousands or 10,000s of images. So if you have this 10,000 image, what do you want to do? Like, do you just want to figure out in this 10,000 image what is cat and what is dog? No, right? So the basic thing that you want to do in machine learning is like you look at your, or rather supervised learning is that you look at your data, whatever you have, and then you want to say something about the data that you don't have. So the unseen data will be this, the rest of the billions of images of cats and dogs beyond this 10,000 of images that you have. So does that answer your question? Because this is very important to understand. Okay, that you have like a pool of known data. So like some images of cats labeled cats and some images of dogs labeled dogs. And what you want to do is like someone just gives you a image of dog or a cat, and then you want to say that whether it's a dog or it's a cat. So that is what I mean by unseen data.
Shubhradeep, if you have any follow-up question, you can ask directly.
Yeah, so because this is a very important point, you have to understand this part first very well.
Shubhradeep? Okay, so
Okay,
we'll
so I
assume you
would
understand. I
think of
understood. Yeah.
it as yes, and then carry on at this point. I'll come back again later.
Yes, sir. I have understood that point actually.
Okay. Okay, cool. That sounds good. Let's see. Okay, yeah. So now, like, let's say you have figured out that, okay, I mean, option one, that line is a good option because it explains the data, and then, like, this is very simple. So you have tick the box of this Occam's razor. Now the question is, like, how do you figure out what line to choose? Then again, the guiding principle is like you want to have good generalization, right? So you want to restrict yourself the least. So how do you like go about it? Is like you take any machine learning problem and then you make it as like an optimization problem. So you want to find the line that gives you the best of some objective. So here, what is done is like you choose this objective that maximize the minimum distance of the line from star or circle. So the line for this particular example, like you see that the star in the left bottom corner is very close to the line. So probably this is not a good option because your minimum distance that is given by this star in the left bottom is very close, like it's very small. So if you like go by this guiding principle, what happens is that you sort of end up realigning this line, and then you come up with this line that has the best performance in terms of this objective that you want to maximize the minimum distance. So what it is called, like this particular algorithm, it's a very popular algorithm even now. Like it's used in a lot of applications over industries, and then it's called support vector machine. So if anyone sort of tries to follow up, they can like do some Google search and then learn about these things. It's, it's still very popularly used. So now the question is like how to find a line, or
I have a question.
yeah,
Why
yeah,
did
yeah.
you take that line? I mean, that particular optimization for the best choice of this line?
Okay. So the question, like again, let's go back to this thing, right? So here, what might happen is that you don't know where the unseen stars and you don't know where the unseen circles are. So what your sort of understanding here is like there is some sort of similarities between the stars and circles, the way they are positioned. So what you want to do is like you want to put the least amount of restriction as possible, and by least amount of restriction, what naturally comes up is like, why do you want this line to be close to a particular like star or a particular circle? So you want to be equally spaced or equally distanced from all the from the examples that are there. So if you just go by this principle, what happens is that you look at all the distances of the stars and circles from this line, and then you decide that you want the maximum possible distance for all of this for all of the points that are there in the plane. So if you want to ensure maximum distance, like maximum possible distance uh, for all the points in the plane, so what will come up if you think a little bit is that the only thing that you can do is like you maximize the minimum distance, because once you have a line, like you'll not have the same distance for all of the points, and then you'll end up with this objective. I mean, depending on like what type of problems you are handling, the objective can be different, but here you can have this one. Does that explain your question?
Okay, that means it actually minimizes the error for the unseen data, actually.
Yeah, I mean, yes, but here you are just going by some sort of principle, right? How do you like you? this principle, like there's a formal way of like figuring out why it minimizes the error, but the idea is like you want to put least possible restriction. So if you are like aligning something, some the line to either the stars or circles, then you are putting more restrictions. So that's the main idea. And it's important to just emphasize on this main idea, because the main sort of key ideas that you have behind the decisions that you are taking, because there are like lots of unknowns, and then you can like sort of take these key ideas and then move to other problems where you will not have the same sort of exact situations. So yeah, I mean it minimizes the error. That is the end goal, but the important thing is like you understand this very key principle that you are putting less restriction on the point, like less restriction on the particular algorithm that you are choosing. So here the algorithm is just choosing a line. So yeah, moving on, what we have to do is like now figure out how to find, like given a set of data points, how to find a line. So there are like infinitely many possible lines. So the thing is, how, given a particular line, the way to improve, like the way to find the optimal line is like gradually improve uh, on the minimum distance that you have. So what you do is like you slowly shift or rotate the line, and then try to improve the minimum distance. So here we can see like you can sort of start off with the first line, and then because you're closer to the star, you moved away from the star and then start moving closer to the circles, and then you eventually come to the optimal possible line. So all of this you can like express mathematically. So you can write equations to figure out what this distance is. Then you can looking at the equations, you can figure out how to decide how much to or rather in which direction to shift and in which direction to rotate, so that you have this slight improvements. So this process of like slowly improving on your objective is called gradient descent, and that is like at the heart of like all the modern uh, machine learning that is done. So someone has a question. Yeah, like go on, just yeah.
How do you know which point to rotate the line around? I mean, how do you find an axis for rotation?
Yeah, so I'm not going into the details of it, so I'm just giving some qualitative. So what you can do, you can just write down the equation for this for the distance of certain points from this from a line. And then line is given by what, like there are many ways to write a line, right? I mean, you can have like a line as like y equal to ax plus b. So the free parameter you have like a and b, and then you try to tune this free parameter. So and that is a like formal, like a mathematical way of writing down the minimum distance in this free parameter as a function of this free parameters a and b, and then you tune a and b to improve it. And I'll not go into the details, so you have to write down all the maths needed, like write down all the equations of how what the distance is as a function of a and b. And what you need to do is like you need to uh, see, like if you change, like if you take a derivative with respect to a, uh, whether increasing a increases your minimum distance or decreasing a increases your minimum distance. And the same goes for b, and then you have to like sort of balance out what to do with both a and b. Or you can like do it like you can first improve on a, and then then next improve on b, and then keep on sort of iterating on that as well. But yeah, but the issue is like you just slowly, like the message that I'm trying to say here is like you you look at the particular the current situation, that you have this initial line, and then you slowly like figure out where, in which direction your improvement is, and then you move to that direction. Does it give some answer to what you asked? Who is that?
Yeah, I think you can continue. Yeah, and also like this is like a more of a general talk, and like machine learning is a huge thing, and
Yeah,
like a
so
huge, yeah. So
yeah, I just did not want to go into because it's a general talk, I don't want to go into the maths of it. And then the maths is like, if you are really interested, you can just search for things like gradient descent, and then you'll be able to figure out how the all the like things goes on in terms of writing down the equations and then figuring out and then coding up the algorithm and things like that. So yeah, it'll be helpful to just go on, look into it for yourself. Yeah, so now I'm coming to the question that was asked, right? How you go about situations where things are clustered in a different way. There are multiple ways to go about. So here you see like you don't have this very nice pattern where you have like the stars in one side, the circles in another side. So what you do is like you allow different functions. That is one option. So here, what the image that is showing now, the one thing that you're doing is like you are now allowing for a function that is like oval set or circular set. So with this, you can see like for this particular situation, you can separate these two out. And then there is another option is like where you add more feature. So here by feature, I mean like you just add some more dimension to the data that you are seeing. So from the existing existing data point. So here what you do is like you compute the distance from, let's say, the center, and then you take this 2D data and take it to 3D. So so the z-axis here, the light blue z-axis is given as like x square plus y square. That will be the distance from center. And then uh, in this example, you see like the stars and the circles sort of separate out in this interesting manner. So now, given that they have separated out, what you do is like you just figure out like what is the linear hyperplane. So hyperplane is like the analog of line in a 2D setting in 3D. So you have like again a similar like linear sort of structure that is given by the hyperplane that separates out this red circles and blue stars. So yeah, and now the question can be like, how do you do this? Like, what is the best way to do it? And then the answer is there is no right answer. Like there is no easy answer to this. L- So people, what they used to do is like they used to try out different sort of features, and if you are going by the second route or if you are going by the first route, you are trying out different sort of class of functions like circle. You don't restrict yourself to lines, and then you go to circles. So if you go back to the Occam's razor, the question is like you want to have simplicity, but then uh, not at the cost of performance up to a certain level. So because if you just come up with line, you cannot separate out the stars and circles effectively. So you have to go beyond line, because that line is simple but not efficient enough. And when you have in the feature space, like you have to like really check out the features. And the way to go about is like you can just try and see what is the performance that you're getting once you do this gradient descent and find the optimal solution from for that the function that you're choosing or the option that you're choosing. So that will give you some guidance in terms of whether the things that you're trying, the features that you're adding or the functions that you're trying are good or not, and then you can reiterate. Now, because this particular part where you are adding features, that is called feature engineering. Now because this adding feature or adding functions is so difficult, then the for more complex problems where you have this images, like, so you can look for CFR10. This is a famous data set that started kind of, or rather was the main thing behind this AI, or rather deep learning revolution that started like a decade back, or maybe 15 years back. And that is uh, that's good to like check out the history if you are interested in this. So here what happens is that you have this feature engineering task that doing manually is very difficult. So what you do is like you come up with this deep learning where you have this input. So input layer will be the image, and then you have this structure where you use this structure to come up with this feature. So the structures are generating the features automatically. So as you like keep on uh, like tuning the structure, your features are also getting tuned, and then you will end up with a very efficient black box, or a very efficient result that sort of strikes the sort of right balance between the simplicity and the efficiency. That is sort of the main thing that is needed for good generalization in machine learning. So generalization is like, again, it's the performance on unseen data. So here, like, I just want to like give a broader sense of like how the research goes on, right? So back propagation is one thing that I don't want, that I will not go into, but that is at the heart of like how you do the deep learning. But as it turns out, like, it's the basic things that you learn in even in your 11 12 that is important, and that you are like using those ideas you'll be using in your like research if you go along this line, like researching on machine learning and related topics. So this back propagation is nothing but just chain rule of derivatives. So you take the derivative for the parameters that are there in a chain rule manner. So the important thing to like sort of keep in mind is like whatever you are learning is going to be useful throughout uh, your career if you are sticking to this line, or yeah, this line of work. So now I'll come back to the engineering part of it. So the engineering part of it is like, what are the things that go into taking this basic ideas that comes from maths and science, and then make it like work in real world. But I think I actually saw some questions earlier, so I let me actually go back to the questions before entering this. So the question is how to find and point out unseen data. So how to find unseen data is not very uh, like, the way I understand how to find unseen data is basically you are saying that, okay, I mean, there is some unseen data that you have to actively find out, but that is not true. Like, what is happening is like someone is coming up to you and then giving you unseen data. It can be like a new image that is given out to you of a like a cat or dog, or like it can be if you are in the retinal setting, someone comes to the doctor and their retinal image is taken, and then that will be the unseen one, because that person, the data about that person was never known. And point out, I do you mean like whether figure out in the examples that I showed, whether it is star or a circle? So that is called prediction, if that is the question. So that essentially is done by the black box that you have designed through the whole process. So you feed the unseen data, and then the black box would just compute what the result is. So whether it's a cat or dog, or whether the retinal image is for a healthy person or a diseased person, that should the black box would point out. It's not manual thing. Okay, so the feature here in C14 database is, what I mean is that, so you don't so you don't go about designing the feature. So that's the whole point of deep learning. So you have this uh, algorithm that can look into the data and then design features for yourself. So you don't have a very clear understanding of what features is getting generated. So I am not sure if that answers your question, but you can. Okay, so let's see. Okay, the next one is like, you are asking. Yeah, so what is happening is that, so I talked about 2D to 3D as feature, so that's why you are asking what is the feature here. So yeah, so I can elaborate on that a little bit more. So you have this, what is an image? So how a computer represents the image is like, you have like pixels, like formed in a matrix form, and each pixel has like the colors and the intensity of the colors. So you just give the whole all of those data as like input. So this is like a very high dimensional data, and then what you do is like, from this data you can uh, input a function and then generate some other data points that okay, so let me actually go back here. So what happens is that you have the input layer, right? So the input layer will be this pixels and their color intensities, and then from there you are going to some other, you are adding this other dimensions. So you're going from this pixel dimension to some hidden dimension, and that would be your like example for 2D to 3D. So you're changing the dimension. So you are like, this new hidden dimensions are basically acting as new features. I mean, it can be like, it's basically just changing the dimension and then coming up with new features, not just sticking to this pixel data of colors and their intensities. So I think that would be it. I can talk more. You can message me if that does not explain, but I'll now go to the engineering part and then I'll come back to the questions again. So, so what, how this GPU, like as you can see, what the one thing that one can point out as the main engineering breakthrough that made the deep learning sort of revolution possible is the group. There is this Stanford group headed by Professor Andrew Ng, who used this GPU. So what is GPUs like? It's graphical processing unit that is used in computers for video and like rendering videos in computer games. So they came up with this ingenious idea of like using this GPUs and then do the training of this neural networks using this GPUs. So what happens is that for deep learning, what you need to do is like, you need to do a lot of matrix multiplication. So like in the range of hundreds of billions. But then CPU is so slow that it cannot handle that much computation using CPU in any amount of like any practical amount of time. Like it will take months to do something that you can do using GPU, which is like very efficient in doing this parallel computations, like parallel matrix multiplication. So you'll take months to do what you can do in like maybe a few hours. Like in 10 hours, what you can do using a GPU, like it might take like 10 days for CPU. So this particular as before this, what was happening? So let's look at the sort of timeline of deep learning. So the ideas behind deep learning was going on from 1940s and all, and then there is a lot of effort that was made to make it more useful in 1970s and 80s, but it never sort of so 1960s and 70s, but it never sort of went off because there was not enough computation power, and also not enough data to the sort of feed into this techniques of deep learning. And what happened is that for many decades, like 1970s to 2010, in this like 4 decades, there was not much of activities. People were working on it, but then suddenly around 2010, this kind of revolution of GPU came about, and then from there, it's predominantly like it's. You can also say that the research that's going on in machine learning is like almost 90% of it might be dominated by deep learning in some form. So these are the engineering like aspect of the basic building block for deep learning. But then if you go beyond deep learning and just look at like how the engineering is done in companies like Google or Facebook, so the yellow section that you're saying, the seeing that basically consists of the whole science part that we talked about. It like it can be as advanced science as you can think of in this field, but it will all be like compactly say like sitting in this small yellow part. And the majority of resources that goes on is in developing this uh, gray part around this yellow part. So what are this gray parts around this yellow parts? There is data collection. So data is like essential, otherwise you don't have any super learning to begin with. So you have to figure out how to collect the data, and then you have to do feature extraction. You have to like create infrastructure that can uh, figure out what features like how to extract the features from the data that you have. Then you have to do in the correctness section of what you have to do is like, you have to do data verification whether the data that you have collected is true or not. Like uh, then there is machine resource management, because there are so many teams that are there in Google that are trying to do the like run some sort of machine learning algorithm for their purpose. You have to come up with a very efficient machine resource management procedure that can do all this computations in parallel to figure out or to have a proper infrastructure. Then you need analysis tools. So the point is like when you have this machine learning code that gives you some result, like how do you connect the result that you get from the machine learning code to the business purpose that you have. So you have to have some sort of analysis tools that can efficiently do certain computations to figure out the result, how the result of the ML code maps to the result of the, or rather to the goals that you have in the business purpose. Then there is like serving infrastructure. So what it means is like you have this designed this ML code, you have figured out this black box. Now you need to take this black box, and then you have to use this black box for billions of prediction tasks for every hour. So at a Google level, that is the challenge of scaling up. And then finally you have to do monitoring, like because not everything is good in the like real world. So you have some understanding when you are in this very theoretical bubble that okay, my data looks like this nicely segregated stars and circles, but what happens in real world, you might start seeing these stars and circles starts moving around. So you have to have this monitoring system in place that can figure out how
the results are, so how the data is changing, or how the ML, the result that you're getting from ML, that is translating into the business purpose that you are that you have set for yourself. So all this very different components come together to have a real world deployment of a machine learning system. So for example, what I do is like I am writing ML code that will, or that is being used to show you some ads on Google Play. So if you have Google Play, you might notice that there are some ads for different apps that is coming up in your Play Store. So, and there are like billions of users, right, of Play Store. So it's not possible to figure out how to, or rather, what are ads to serve to this billions of users manually. So you set up all this infrastructure and then end up serving billions of users the best possible ads that can take them to the sort of apps they want to have or they're looking for. So yeah, so I think I will conclude this section with like this one, uh, and then go move to my journey. But then the question is like, how do you navigate, like if you're moving into some sort of engineering uh like college after your 12th, or if you're already in your like first or second years in engineering, so how, what are the ways to navigate it? So I think like the very important thing is like you try to learn about the basic ideas that are coming from science. You don't need to know all the details of maths, but you need to know the basic ideas like this Occam's razors, how to do feature engineering, and why you are doing it. And then you have to understand like the issues that are rising from engineering. So let's say you have a CPU, like you don't have GPU. So what are the machine learning algorithms that you can use in that circumstance? Things like that will be guided by engineering at your level. And the best way to go about is like just keep on searching for like blogs on ML or AI, and then like there are lots of interesting YouTube videos that are there that will either go into the breadth of subject, like what new cool things are happening in this, or it will go into the depths of a like a particular paper, or a particular idea. So those are the things that you should look at. Then of course, like there is nothing better than hands-on experience. You code up some ML algorithm, see how it performs, you participate in Kaggle competitions. I mean, you may not know what Kaggle competition is at this point, but you can just search it up and then see like these are uh, like very state of the art problems that are open to public, and there are many sort of researchers or ML enthusiasts who try to take a shot at solving those problems. And then keep an eye out for new topics like fairness and privacy. I'll not go into the details of it. I just want to introduce this keywords so that you can search and then look for what uh, is going on there. So now is the time to go back to the uh, questions and then end up with my journey. So let's see what are some of the basic ML algorithms to begin with. So let me actually uh, give the answer in chat. So so the first thing to start with, uh, it's called linear regression. So it's about some continuous like predicting some continuous value for the input. So linear regression, then logistic regression, that that is used for this cat dog type simple classification problems. Then you can look for SVM, that is the support vector machines, and of course look for neural networks. So these are the sort of basic things that you can look for. But start off with this linear regression and logistic regression. This particular order, I think, helps. Is there any other question? Like, just feel free to ask.
There
I
is
want to ask something.
Okay.
Um, when we sometimes do something and there is requirement for verification, then we are often shown some pictures like that of a lamppost or that of a post box, and we are asked to say that if we can actually identify that. And also sometimes we are given some jumbled sort of texts, and they call it just for verification that if we are not robot. What does that mean? Is that any connection to do with this machine learning or something?
I mean, there need not be any connection. So what happens is that those tasks are very easy for humans to do, but then for machines, it's not that easy. Like you need very, very, very advanced algorithms to figure those tasks out. So you cannot have a bot that does this thing easily. So that is like a privacy uh, that is used for privacy, right? So yeah, I mean, it does not have anything to do with machine learning as such.
No,
But
no. So what he was asking the capture too, correct? When you work in the robots, like when you just log in, like sometimes they ask like this is the bridge, this is yeah,
yeah,
lamppost or something like that. Like, is there like there are they kind of using this data for some kind of labeling, or like yeah, I think that is kind of the query.
was that the question?
Yeah, just to make sure.
Yes, please answer that.
I mean, so is the question like whether the data is taken and then used for some machine learning purpose, or is that the question?
Yes,
Or
that is my point. That there is connection with this kind of survey with machine
I
learning.
mean, I'm not sure about that actually. I mean, there are so much data that is there already. I mean, I don't think at this point people are using that to run any uh, like algorithm. I mean, in principle, you can do it, but I just don't know exactly whether it's done or not. In principle, you can use like that as a label, like whether there is a card in this picture or not. And then if someone clicks, then yeah, I mean, that is a label that you get. But I don't think it's used. Yeah, I don't think I know exactly whether it's used or not. Yeah, sorry, I cannot. I don't have the exact answer that you're looking for. Yeah, now everyone can like just go and ask the questions directly for some time.
Sir, uh, I had a question that in case of the supervised learning, uh, we fed some unknown data into the computer, and then it gave out a label, and in between we have a black box, right? So
Mhm.
we actually don't know what the algorithm is doing. So like, let's say we design an algorithm and let it run such that like we design a self learning algorithm, and then we let it run, and after some time, then do we know what it has learned, like how the patterns are related? I mean, my
Yeah, so
question is ki,
basically, yeah, it's learning, right? So what happens in the supervised learning setting is you look at like, okay, so how do you go about it? That's a good question. So what you have some known data, right? So you keep a bunch of data aside, and then you don't touch the data, and from that like separate data set, you take out like image and then see what the algorithm is predicting, and on that separate data set you test the accuracy of the algorithm. So that's how you figure out whether the algorithm is good or not. So this is called like validation of algorithm.
okay, sir, but my question is like, okay, let's take an example that let's take
Okay.
Alpha Zero. Alpha Zero was a chess playing algorithm, I think. So
Yeah, I'm
uh,
okay.
it
I
was
think like the point is just let me say one thing. So Alpha Zero is like a different thing. So I talked about supervised learning. So it's not supervised learning, Alpha Zero. It's like a separate thing. It's reinforcement learning. So there you don't really have a like any connection with like any direct connection or close connection with supervised learning. So
okay, sir.
yeah,
So
but go on with the question. Yeah.
let's imagine there is some algorithm which plays some game
Okay.
very efficiently, and what it does is it learns from experience. It sees what has happened and just learns and learns and learns and discards the wrong things. Now after we have let it run for some time, can we just look into the black box and see how it judges that this position is right or this position is good or that position is bad? And can that like chess grandmasters, can they sit down and learn from the algorithm so that they can be better at their own games?
Yeah, I think they are like they are doing it. I mean, I read something about that people are trying to run. So if they're like in certain position in the board, then they're trying to see what the AI AI will do, and then what kind of strategy they will come up with. So if there are like some patterns that AI are following and that humans have not followed, then like human champions, they can also learn from AIs.
Yeah, so people are actually like, I follow different chess stream. I can just kind of add to that. So you see, like the elo rating of the Magnus Carlsen is like around 2800, but like the actual, I think Alpha Zero also the stock fees is around 3200 or more than that. So actually they learn for that, they study that, and they kind of try to understand from that. This has like already been started like, for last 5-10 years. So they actually do actively that, and obviously they try to do consult with another grandmaster, have their seconds and like discuss. But they're also started learning from the machines ideas, right? At least get another
Chase
idea
has been like
to
yeah, chase in chase I think machines become superior than humans like a long time back. So yeah, it has been like decades now. You can learn from the machines in chase.
Yeah, and like now if it is 200 games, it's very rarely like the chance that human could win, because there is a huge gap. It's like yeah, so there is some noise coming, if anyone kind of mute. Yeah, okay.
Sir, I have a question.
Yes.
Uh, when we integrate all this ML or DL models in some web apps, then how does this GPU resource thing is handled in the server?
Okay, let me try to understand what you are saying here. So you are in like in a simple web app that you want to design, or the web apps that are there in Google?
No, a simple one.
Simple one that you will do is like there will be a server in your like a code for server in your laptop, right? And then that server will call another like you'll be running like some machine learning algorithm in the loop. So one thing that I need to sort of clarify at this point is thing like the GPUs that are mostly like needed for doing the training. So when you have a web app, so most likely you have done the training offline, or in most of the time that happens that the training is done offline. So what you do is like just prediction in the web app. So what happens is that you don't need that kind of resources. But yeah, that like now coming back to the point, yeah, you can have a code that just that is called through web apps, and then you can let that code handle it. I mean, I think I don't maybe I don't understand your question. Does that answer your question? Like you have a
Yes.
code running that runs the web app, that's server for the web app, and then that server will call another code, and then that code will handle the GPU resource management, or the OS coupled with the code will handle the GPU resource management in a simple system, like if you are running it. Yeah.
Okay. Okay. Thank you, sir.
Any, yeah. Any other question at this point?
No, you can kind of continue and conclude.
Okay, I
Then,
think
yeah.
it's like I have already ended. So just my journey, I think. So I am from Bagnan, Howrah. I don't know if any of you know about this place, but yeah, I studied there till 12th, and then I just like to know about new things like maths. I loved maths, but then I was also like interested in, let's say, biology, history, and things like that. And then the love for maths sort of took me to IIT Kharagpur, and then there I sort of enjoyed my stay. I like what I sort of remember the most is like making friends, participating in hall events, then like picking up the hobby of watching nice movies, listening to diverse music, and stuff like that. And of course, like I learned a few things on the way. And then from there, I moved to US as a PhD student in UT Austin, and there also like it's not that much in the past, so I remember more things. But what I will stay with me, I think, the friendships that I developed, the road trips, the memories in that. Then again, watching some more movies, some with Swadhin as well. And then yeah, like, and one thing that is very important is the learning experience that I had during my PhD, where you navigate things on your own, and then you sort of learn a lot of interesting state of the art things that's happening, and you see how the things that you have learned during your maybe early college days, or even your 11 12 standards, that comes up uh, in understanding some of the very complex things. Like you won't like if you are not in that position, you won't believe how basic calculus, basic algebra actually like plays the most crucial role in uh, like developing new theories, like developing new understanding. Yeah, then I joined Google. Not much happened from then because I already was under lockdown for the whole time. Yeah, so that's about it. I think any other question, specific question about like what
Yeah.
you want to do, or
Yeah. So there is a question about your PhD research. What was the like big idea? What did you work on that your during your
oh
PhD?
yeah, so I didn't. So what I worked on is something related to reinforcement learning. So what there is something called bandits, that is like very simple instances of reinforcement learning. But what I did is like I did some sort of theoretical research in that area, and then developed some understanding of it. I mean, I don't want to go into the details of it, but because I have not discussed anything about it. So that's the problem. But yeah, like look for things like bandits where you. So the key thing that I looked into is that okay, so you have some resources where you don't know how good those resources are, and what you need to do is like you need to sort of use the resource to understand how good that is. But then if you like pick up a bad resource, you lose some reward. So it's this tension between like figuring out what the resource, how good the resources are, and then not losing reward while figuring that out. And this, yeah, this is called the explore and exploit in reinforcement learning. And that some part of that I tried to look at. Yeah. Yeah, thanks. Yeah, whatever the keywords that Swadhin has posted. I think those are the things that I looked into.
Yes, so I just want to kind of stress upon, like he mentioned, like this is like the main thing is learning. Like I am still learning, he's learning. You see, after 12, you have like he has done 5 years of BTech and MTech, then again 6 years, then this is another 1 year of working almost. So 12 years, then the more you learn, and there is no shortcut, at least for me. And the more you learn, you know, the less you know, and you kind of the questions you are having, like you kind of same questions you ask again and again, you kind of understand more. I think Shomu can add more on that, like this kind of lifelong journey, like lifelong learning and kind of doing for a longer
Yeah.
period of time is very critical.
Yeah, exactly. I mean, like, so the point is like there will always be new ideas that are coming up. So you will never be in a position where you know all the important things that are there to be known. So, for example, when we started our PhD journey, that is the time when this deep learning and things like that started becoming uh, like started coming into the mainstream. So for a professor who at that point does not know about this thing, so what they have to do is like they have to go back and then start learning the new things that are coming up. So the point is like you can never stop learning, as Swadhin mentioned, and you cannot stop asking questions about that. You just keep on your hunger about knowledge. I think that's the most important thing, and just don't think about like where it will lead to, because that's a question that's very uncertain. So just keep on the hunger, and then uh yeah, just keep on learning, and yeah, enjoy the process while
So
doing
there
that.
is a question, like a very broad philosophical question, I guess. Like, how do you use machine learning to kind of predict the future? How to know about the past? Can the Big Bang, origin of universe, etc., can be
I
answered
mean,
more accurately through
this,
machine learning?
I mean, this is a very broad question, and the answer is like we don't know yet, right? We have just started to like use machine learning beyond some simple situations of this image classification and things like that. So AlphaFold is a very important achievement in this regard, right? So the protein folding is useful in very important things like medicine, discovery of medicine, and figuring out some biological processes, and that uh, so yeah, we'll go like in the coming decades. I think we'll use some of these ideas uh, in solving problems in physics, chemistry, and like basic sciences. There are efforts that are going on, but to be honest, I don't know how to answer that, because no one knows at this point.
Okay. So one more question I think some of you might have. I'm just asking, like people, some of them are in school, are preparing for entrance exam, multiple entrance exams, correct? And even if there is anyone from college, they will be giving multiple exams. So you have given many of the exams and coming from like smaller town, like, and also like what is your process and everything? Like if you can give a like sense of it, I think it will be also be helpful for other students.
Yeah, sure. So going back to my 12 days when I was studying for different exams, I mean, it was so I took up some sort of online tuition about IITs. So there's this thing called Brilliant Tutorials or something, which will send you some materials that that will help you prepare for some of the like the topics that are generally not covered in the West Bengal curriculum, and then that is covered in the IIT JEE curriculum. So that from those things I learned about it, and obviously the most important thing is like going through the problems, giving mock tests, and uh, yeah, I think these are the things that you have just keep on doing, and then yeah, and then the final thing is like how you perform the last day. I think the main question is like first picking up the right materials that is needed, like for example, for me, like for IITs, it was the materials that were sent from this brilliant tutorials, and then there are some books like the book by H.C. Verma, and uh, yeah, that's what I can remember at this point. But yeah, just pick up the right materials and then study hard and then give a lot of mock tests, and you should just be like confident while going into the tests. And that goes like even if you're studying for like West Bengal JE, I don't know if it is even there. Like things have changed, right? So do they have state exams right now? I'm not sure.
No, they still have. But what I think, what he is also trying to say is the exact. You see, the books and things and the coaching materials. He might not remember, but I think going deep and studying really well, understanding, and also I guess want to point out, like, even if it does not work out, like whatever you are looking for, if you keep on working on it, like over time, like you get your opportunity, you will get your things. It is not like this is do it or less, correct? Because unless you
Yeah, I
can do
mean
anything.
there are so many options. I mean, if you look at the possibilities in that sense, yes. I mean, there is one aspect of like how do you prepare for the entrance exams. So I was trying to answer that. So there, yeah, I mean, just try to understand the material and then do a lot of practice. But beyond that, as Swadhin mentioned, right? I mean, there is no shortage of opportunities. So even if you like don't succeed, you should just think of there are two possible ways. Like you can just like try harder for that next time, and you will most likely crack it. Or even if you don't, then there are like other options. There are there are so many successful people whom I have known now who have like studied like basic sciences, who has not gone in engineering, and then there are so many people who has gone in engineering and then they have ended up pursuing their own hobbies and things like that. So it's just a learning process. Give your best and then don't worry too much about the results that you end up with, because there is always like other options. There is always the future that
We'll
lies.
be wrapping up within 5 minutes. If anyone has any last questions, they can directly
Yeah.
ask. Otherwise, I will kind of conclude that and thank the speaker. It seems like there is not any questions coming. Yeah, last call. Any questions you can ask directly, or you can write it down. So yeah, I think there is not any more question. So I thank Soumya for getting his time. He's in California currently, and it's like early in the morning, and waking up and doing this. And hopefully, I have recorded. It was kind of broken. Um, but thank you for doing this, and I think this will be the main thing is this one talk is not enough. There are some pointers, some keywords you have to search, and the immense thing you guys have and you are very good at is internet and searching in the internet. What in our school days we are not aware of this. We kind of in the later college days, or we kind of get hold of that, or with a smartphone you can kind of get hold of that. Use your time, use your thinking. There are so many videos, so many online resources, and everything for free. So I guess that is would be my overarching suggestion. And again, thanks Soumya for doing this.